So this just says Ellie's comparing prices for dinners at 2 restaurants. The dot plots below display the prices. So the first dot plot is restaurant 1, the second one, or restaurant A and restaurant B. How would you compare the standard deviation? Okay, so if you're looking at the dot plot, you do not have to calculate the standard deviation. You could if you were bored, I guess. What would you tell me, which one's standard deviation do you think is lower? Because?
It has a smaller range.
Yes. Okay, the more spread out the data is, the larger the standard deviation. So maybe something like A has a lower, and again, these will be multiple choice. You won't have to write this out. So A has a lower standard deviation. And I'm going to say it's less spread out. The data is kind of concentrated in one area. Maybe another way, it'll be multiple choice. We could say, I could almost make a similar argument. I could say B has a higher standard deviation, and I could say because it's more spread out. The more spread out the data is, the higher the standard deviation will be. The less spread out the data is, the lower the standard deviation would be. All right. Now, this guy right here, and there's one like this on the test, and it literally only has 5 data values. It says find the outlier if one exists. So if you notice the values that I have there, do you feel like one of them would probably be an outlier? I got 53, 57, 62, 64, and 90. You would think. Okay, now, if you actually calculate this real quick, the median of this data set, right in the middle, would be the 62. And it's a super small data set, so I'm just going to do this by hand real quick. That would be the median. If you want to find outliers, you need the Q1 and the Q3. So I'm just going to show you real quick. If your median is one of the data values, which it is here, then the Q1 is the median just of the left side of that. This is only 2 values. So your Q1 would just be an average of those 2 values. So if I did 57 and 53, let's see, what would that be? 55, right? And now on this end, your Q3 is going to be the average of 64 and 90. And yes, I am grabbing my calculator right now to do that. So thank you. Okay, so 55, 77. So I'm just going to remind you real quick. So outliers are any number below Q1 minus 1.5 times your interquartile range. Your interquartile range would just be to subtract Q1 from Q3, so that's just going to be 22. All right, so if I do the lower bound, my Q1, I got 55, and I'm going to do minus 1.5 times 22. And I'm just going to show this to you because I feel like you're not going to, or you're going to think I'm making it up. But anyway, this is actually 22. So any number below 22, which in that list of data does not exist. You were telling me when we looked at that maybe the 90 would be. So anything above Q3 plus 1.5 times the interquartile range. So our Q3 was 77 plus 1.5 times 22. This gives you 110. So any number above that, and 90 is not actually above that. So there is no outlier here. Even though, like, looking at the data set, I would have thought the same thing. If you actually do the math, there is no outlier there. Okay, now I'm going to have you guys review here with me real quick. You can sketch this if you want to and kind of figure it out if you wanted to make a scatter plot, but I would just tell you to use the calculator to do it because it'll make it a little bit faster. So I'm just going to jot down the calculator directions to do this. So I'm going to hit Stat, and then I'm going to hit Enter. And I'm going to type X in that first column, which is list 1, and I'm going to type Y in the second column, which will be list 2. That might be, if you don't remember how to do this, that might be something I would take a little tiny bit of space on my little cheat sheet. So I'm going to do stat edit, and I'm just, if I've got data in here, just arrow up to the top of the column so it's highlighted, hit enter, or hit clear and hit enter, and it'll wipe all the information out. The X values, 0, 1, 3, 5, 6, and 7. And then the Y values, just trying to match them up. You got to hit enter in between each one. Okay, once you do that, to look at a scatter plot, I'm going to hit that zoom button, and it's number 9 is zoom stat, and that should give you a scatter plot. But just real quick before we do that, let me go, because somebody may have turned it off or you may have turned it off. If you go to the y equals, up at the very top, you have to have plot 1 with a black background. If it doesn't have that, it won't show you a scatter plot. It's super easy to turn that on and off. Just arrow up to the top, hit enter, and arrow away from it. You can turn it off. Arrow up to the top, hit enter, arrow away from it, and you can turn it on. So just, you need that on though if you want to look at a scatter plot. So make sure you got that highlighted. And then I'm just going to do zoom number 9. And if I look at that, what, bless you, what shape would you tell me that looks like? Like a line, a parabola, or an exponential? Parabola, right? All right, so now what I want, once you decide the shape, then to get the equation for it, you're going to hit stat. And when you hit that button, you're going to arrow over to the calc menu. You're not going to have to give me like an R value or anything like that for the correlation for this on the test. It'll literally just be the equation. So I'm doing stat, calc, and then if you think it's a parabola, you want the quadratic regression. It says quadrag. So I'm going to either arrow down and hit enter, or you can hit the number 5. And then just keep hitting enter until it shows up on the screen. Now, on the actual multiple choice on the test, one of the equations will be a line, one of them will be an exponential, one of them will be a quadratic. So you'll be able to eliminate several of the options just right away. But it doesn't do a ton of decimal places. I think it just does 2 decimal places. So for this one, my A value, I'd write maybe like negative 12 point. That's going to round to 12.9 if I round to 2 decimal places, x squared, and then plus 73.88x, and then plus 83.04. One of these ones?
Yes.
I think I got some. Yes. Okay, now, we don't have any matching on the actual final. There will be one question about correlation, which is going to be the R value. They're all going to be linear in nature. And so basically, if it looks like a line with a negative slope, then it's going to have a negative R value. If it looks like a line with a positive slope, it has a positive R value. The closer it is to like a plane line, the larger the R value would be. All right. Now, let me just start. Let's just eliminate. Which one do you think is 0 on here? Which one do you think no correlation? F, yes. I thought I heard somebody say it actually. Okay. Now, let's see. Which one of those numbers, this is positive, right? This is going up from left to right. Which one of those R values do you think is best represented for letter C? For sure. All right, so we use that. That's pretty linear. Okay, now these other ones are a little bit more loose. So this first one, that would trend as a positive slope, so I'm looking for a positive R value. This one underneath it looks pretty similar, but it's got a negative trend to it, so it'd be a negative slope. those are pretty, I mean, they're decently close together, but they're not as close together as this first one. So I think these two are going to go with the 0.7s. Now, the one with the positive slope is going to go with the positive R value. The one with the negative slope going down from left to right is going to go with the negative value. And then these two are pretty similar. I would argue here this would trend in a positive slope and this one would trend in a negative slope. So the other two numbers I have, the positive, this is a little bit looser, so this is going to be E. This is maybe just a little bit tighter compared to that, so that's going to go with B. All right, there is a little question at the bottom of the page, so let's just do this real quick. Okay, identify the sampling method. It says Disney wants to determine the favorite movie of their Disney Plus subscribers. They send out a mass text to the account manager for each Disney Plus account and record the responses. So it's not whether this is good or not, it's just what type of sample method are they using here. If they send out a text and they're waiting for your response, so if selected, it has to be D. All right. Now, here's another sampling method. This says Disney wants to determine the favorite movie of their Disney Plus subscribers. Disney sends a representative to interview customers as they enter Disney World. This is convenience for sure. Okay. Now, there's a weird question like this on the test, so I made a really similar problem here. Okay, it says if 2 dice are rolled, the theoretical probability, like what should happen, of rolling doubles, so like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. If you think about those little charts that we made forever ago with the probability of rolling 2 dice, there would be 6 of those. The 1, 1, 2, 2, 3, 3, that group I just listed, there were 36 possible options. So that's what this is. 6 out of the total 36 would represent rolling doubles. That reduces to 1/6. That would be the theoretical probability. Okay, does this probability mean that if you definitely roll 2 dice and we do it 6 times, one of the rolls has to be doubles? So if I roll dice 6 times, that ensures that one of the rolls is going to be doubles. And then you're going to just tell me yes or no. Okay, so it says yes, it means if 2 dice are rolled 6 times, at least one of the rolls has to be doubles. No, no way. Okay, no, it means that if 2 dice are rolled many times, about 1/6 of the rolls would be doubles. I'm going to hold off on that. Yes, it means if 2 dice are rolled 6 times, exactly one of the rolls would be doubles. No way. All right, no, it means if 2 dice are rolled many times, at most 1/6 of the rolls would be doubles. It's got to be this one. If we would do it many, many times over, that's about that would be what we would expect, but it doesn't ensure anything if you actually did a trial. All right, now I have one of each of these. There's just one on the test, and I honestly can't remember if it's a permutation or a combination, but I just wanted to remind you the calculator buttons for these. So if you all have a scientific calculator, you're going to type the number, and then you're going to hit, it's a PRB button, and then you're going to fill in the other number when you select the NPR or the NCR. The first one we're going to do a permutation. This is if you have a scientific. All right, if you have a graphing calculator, you're going to type the number, the first number, you're going to hit math, and you arrow over. Some of them say why did I just do that twice? Some of them say PRB and some of them say PROB. It just depends on which calculator you have. I've got my graphing calculator up here, so I'll show you mine. But if I just do math, arrow over probability, and then the permutation is the P, the combination is the C. So if you need help finding that, scientific calculators have that too. Let me go back to the main screen real quick. So I'm going to do 8 math, and then if I want permutation, I just pick the NPR, and then you fill in the second number. So this should be 336. If I do a combination, it's those same buttons, but it's just a different piece of the menu. Same number, so I'm going to do 8 math, and then probability menu, and for C you pick the one that says C, and then you fill in the other number. You have to hit enter after you pick it. So this should be 56. There's one of those on the test. I honestly can't remember which one, but again, if you want to write down the calculator directions for that, just to remind yourself, whichever calculator you have. Okay, create a code for a digital safe. You have to choose 3 letters, followed by 4 single digits. So 1, 2, 3, 4. All right, how many codes are possible if repetition, that means you can repeat values. All right, so A through Z, how many letters are in the alphabet? 26. Okay, so I'm going to do 3 letters. I can repeat the letters, so each one of these slots would have 26 options because I can pick any letter in the alphabet. Okay, now, this always messes people up, but 0 is a digit. So if I can use these digits 0 through 9, there are 10 different digits. And we're going to have 4 digits for this code. So it's just 10, 10, 10, 10. I can repeat the letters. So I can have 10 options for each of those spots in the code we're trying to create here. To get the actual answer here, it's going to be a huge number. You're just going to multiply these together. I did 26 3 times, and I did 10 4 times. So I'm just multiplying those both. You can actually write out like 26 times 26 times 26. I was just using my exponent there. So, oh my goodness, what is this? 1 7 5 7 6 1 2 3 4. So it is 175,760,000. There is a question that asks you to find the mean of a data set. If you want to type this in and use the X bar, you can. I would maybe argue with you that it's probably faster to just do it by hand real quick. So we're just going to add these up. So I've got 9, 12, 15, 18. I'm just adding these up. 23 twice and 24. So I got 124, and you would divide that by how many data values you have. So it looks like here I have 7 data values. Yes. So I'm just going to take that, divide that by 7. That'll be my mean. And I'm just going to go 1 decimal place here, about 17.7. If you do want to do it on the calculator, that'll be the X bar. But I think by the time you type all the data in, it might just be faster to do it by hand because they're not going to give you a huge number of data values. The median, this will be super easy. I'm just going to cut off numbers on either end to get to the middle. So just 1 on each end. And in this case, I have an odd number of data values, so the median is right in the middle there. It's going to be 90. And then these last 2 questions go with this table here. So it says a study of speeding violations and drivers who use cell phones was conducted with the data represented below. So you have a speeding violation in the last year, no speeding violation in the last year. Then you have using a cell phone and not using a cell phone while they're driving. Okay, what's the probability person selected at random from this group had a speeding violation in the last year? So what's the probability you have a speeding violation? Can't spell apparently. Perfect. Speeding violation, I would take the total here out of the total number of people in this table. Okay, so let me see what that is. I'm going to have to look this up. I don't know if this is written as a decimal or a fraction. If it's a fraction, you got to put it in lowest terms. So it'd be 14 out of 151. If it asks you for a decimal, I'm just going to write 3 decimal places. So it'd be about 9.3%, but as a decimal, 0.093. Okay, now, the way this is written out, it's actually like written out instead of like a P with a parenthesis. So let me do this here real quick for you. What's the probability person selected at random uses their cell phone while driving? So uses their phone, given, so that's where I had the little bar, given that they had a speeding violation. if you have something that is given to you and you are looking at a table, whatever is given to you, so it's given that they had a speeding violation, don't even mess around with the other column in that table. We're just going to use this one. Okay, so given that I'm in this column, given that I had a speeding violation, what's the probability they were using their phone? 25 out of 70. You don't use the whole table if you have a conditional probability where something's given to you. If they had given me that they used their cell phone, then I would just use that row. So that's how that works. It could be you just use a column or you just use a table. What does this reduce to? And it says 5/14 as a reduced fraction, or as a decimal, I'm going to go 0.357, so about 35.7%. And I just can't remember how the multiple choice is on the test, but one of those two. None of them ask them as a percentage.